All right, guys, welcome back. So this week we're going to continue working with factoring. And this first video, we're going to review again factoring trinomials, but this time with a GCF. So what I mean by that is last week we saw a bunch of examples that looked like this, where this first term right here was always x squared. Another way of saying that is that a was always 1, and that's what I mean down here. Because when we look at it just filled in with letters A, B, C, we never saw it where this was something different like 5x squared. It was always just 1x squared, so we always just wrote it like this, x squared. And let's remember and review how we would factor trinomials like this. We knew that when we broke it apart into two sets of parentheses, which each one of them would have a binomial, 2 terms in it, we were looking for numbers that multiply to give you that last term and add to give you this middle term. So the easiest way of doing it is just starting to list out the factors of that last term, the C term, and in this case is 34. So let's go over here to the side and list out factors of 34. Well, I could do 1 times 34. I could do 2 times 17. And if you're unsure about factors from here, you can literally just type them in on your calculator, like 34 divided by 3. That doesn't work, so 3 is not a factor. 34 divided by 4 doesn't work. 34 divided by 5 doesn't work. 34 divided by 6 doesn't work. Like, just keep going through and see if you can find any other factors of 34. Okay, and I can't find any other factors. So these are the only ones. And then we're going to choose the one that would also add to get me to 19, which obviously would be 2 plus 17, where both the 2 and the 17 are positive. So now I'm going to come back to my parentheses and fill that in. X plus 2, x plus 17. And now I know that if I FOIL this out, so if I take this first term x and multiply it to both terms in the second one, and take this positive 2 and multiply that to both terms in the second one, let's actually do that and see what we would get. Well, this first one, taking x and multiplying it to both, gives me x squared plus 17x. Then taking the positive 2 and doing the same thing, we would get plus 2x plus 34. And the only thing I can combine together here would be that 17x plus 2x, which gives me 19x. And if you look, that matches the original. So then I know that my answer was correct. So let me clear the screen and just write our answer nice and neat. It was x plus 2, x plus 17. That is the factored version of this trinomial. Okay, let's do it again, this time with a negative number for our C term. So if we have negative 12, how does that affect it? Well, we're still going to do the exact same thing. We're still going to write out factors of 12, so that would be 1 times 12, 2 times 6, and 3 times 4. Except for we do need to consider that it was a negative 12. So in each of these cases, each one of these options for factors, one of the numbers has to be negative. So if I look at like the 3 and the 4, the 3 and the 4 cannot both be negative because otherwise if you multiply that together, you'd get positive 12. So either the 3 is a negative or the 4 is a negative, but not both. Okay, so let's try and pick one that would add to get me to 4. Well, 1 and 12, if one of them is negative, you would either get 11 or negative 11. So neither of those work, so that's out. 2 and 6, if the 2 is a negative, then it would be 6 minus 2, which is 4. So that does work. So I want to use this choice with the 2 and the 6, but I need to make sure that the 2 is the negative. That way it reads 6 minus 2. So let's write that down. Make the 2 the negative and make the 6 the positive, because positive 6 and negative 2 add together to get me 4. And also negative 2 and positive 6 multiply together to get me to negative 12. So then I know I have the correct factors. Okay. So let's look at cases where the first term, this term right here, the x squareds, let's look and see what happens when that is not a 1. So in this case right here, we can see right away it has a 5 there. So the first step is if there's a GCF, you definitely want to do that first. So when I look at all of these, 5, 15, and 10, I can see that they can be divided by 5. So I'm going to divide every term by 5 and take that out and divide it out into the front. And what would be left is x squared plus 15 divided by 5 is 3, and 10 divided by 5 is 2. So if I divide a 5 out, this is what would be left. The way I can check my answer is just go ahead and multiply it back into everything and ensure that you get the exact same thing we started with. Okay, so now from here, I'm going to factor this part like we just did in the last slide. So I'm just going to leave that times 5 on the front and break down the parentheses into 2 parentheses. Okay, so let's do it like normal. Write your factors of 2. The only factors are 1 and 2. And luckily, 1 plus 2 also adds together to get me to 3. So I know my answer would be x plus 1 and x plus 2. So that was a pretty easy one because there wasn't very many factors of 2 to think through. So this is my final answer. I first took the GCF out, and then I just factored like normal, and I got what was left in parentheses. And that's it. So taking out a GCF is definitely a really important first step that's going to help make everything a lot more simple after. Okay, so let's do a few more. I can see in this example here that there is a leading coefficient of 4. So let's see if all of these things can be divided by 4. So check that out on your calculator right now. Does 60 divide by 4? Does 32 divide by 4? Do all those things divide by 4? And the answer is yes, they do. So let's divide out a 4 from all of it and write what is left. So if I divide out a 4, then this would just be x squared. 32x divided by 4 would be 8x. And 60 divided by 4 is 15. So that last term would be plus 15. So I've taken out a 4, and now this first term right here does not have a number in front of it. It's just x squared. So now we can factor like normal. Write out your factors of 15, which would be 1 times 15 and 3 times 5, and that's it. And choose the one that would also add to get to 8, which would be the 3 and the 5. So this 4 that we wrote out in front is just going to hang out in front the entire time. And then we'll write in our factors. So we know that we're choosing the 3 and the 5 because 3 plus 5 is 8, and 3 times 5 is 15. So I'll write x plus 3, x plus 5. And remember that it doesn't matter if you write these in flip-flop order. Like I could have said x plus 5 first and then x plus 3 second, and that's still the exact same thing. And we're done. So taking out that GCF first makes the rest of the problem really easy, and it just goes to exactly what we did last week. All right, let's do number 2. So I have a leading coefficient of 8. See if everything in here can be divided by 8. So pause the screen now, test that out, and see what you get. All right, so when you divide everything by 8, or you take out an 8 from everything, what you would have left is, in the first term, it would just be x squared. Negative 56x divided by 8 is negative 7x, and 48 divided by 8 is 6. And now right here in the green parentheses is just a regular trinomial where the leading coefficient is 1. So I can factor like normal. Write your factors of 6. That would be 1 times 6 and 2 times 3. And you're going to choose the ones that will allow you to add to get to negative 7. Well, that would work if you did 1 and 6, but you made them both negative. Because negative 1 plus negative 6 is negative 7. And let's just double check. If both of these are negative, would that also multiply together to still get me a positive 6? Yes, it would, because negative 1 times negative 6 is positive 6. So then I know I'm going to factor it like this. X minus 1 and x minus 6. It doesn't matter if you did the minus 6 first. We just know that we need to use those numbers in our factors. And that's my final answer. I took out the 8, I took out the GCF, and then I factored the remaining trinomial like normal. Okay, let's do the third one, and then I'm going to have you guys do the fourth one completely on your own. So this third one, I see that there's a leading coefficient of 3. Check and see if these other terms can be divided by 3. Okay, and when you check that, you'd see that everything does divide by 3. 18 divided by 3 is 6, so that would be negative 6a. And negative 21 divided by 3 is negative 7. So now I just have a leading coefficient of 1 here. There's no number in front of that a squared, so we can just factor like normal. Write out factors of 7. The only factors of 7 are 1 times 7. And choose the ones that would add to get you to negative 6. Well, remember this was a negative 7, so one of these numbers has to be negative, and I can get to negative 6 if the 7 is negative. because if you do 1 plus negative 7, that gets you to negative 6. So remember, this 3 just stays here, and the rest of it we'll write a plus 1 and a minus 7. It doesn't matter what order you write that in as long as you have both of those factors. Remember always that you can factor this back out and check your answer. Okay, so at this point, pause the screen if you need to look at any of these answers. I'm going to clear the screen and have you guys try this one down here completely on your own, and then hit play when you're ready to check. So pause here now if you need to look at the screen. Okay, so now go ahead and do number 4 completely on your own and hit play when you're ready to check it. Okay, so I'm guessing that a lot of us started off by factoring like this, recognizing that you can divide everything by 5, but then it's kind of tricky because you don't have a squared term. See how all these other ones was x squared, a squared, now all of a sudden it's m cubed? So how do we factor when there's a cube? And also, this is not just a regular number, there's a variable still, which means there must have been something else that we could have taken out besides 7. Notice in the original problem, this has an m, this has an m, and this has an m. In fact, this has 3 m's, this has 2 m's, and this has 1 m, which means you can at least take out 1 m from everything. So instead of just taking out a 5, you want to actually take out a 5m from everything, and what would be left if you took out 5m is in this first term you would have m squared, in the second one you would have 6m, and in the last one you would just have 7 because you took out the m. So all the m's dropped down by 1. This one had 3 and now it has 2 because we took 1 out. This one had 2 and it only has 1 because we took 1 out over here. This one had 1 and now there's none. So you want to be sure that when you take out the GCF, you're also taking out any letters if applicable. And this was the first example we've seen where there were letters that you could take out. Okay, so now from here, we're going to just factor the rest like normal. So I'm going to leave the 5m just kind of hanging out in front the whole time. And now we're going to factor the trinomial, this part right here, into 2 binomials in the red parentheses. So we can do that like normal by writing out factors of 7. And the only factors of 7 is 1 times 7. But this was actually negative 7, so think about which number has to be negative in order to add to get you to 6. Well, if you do 7 minus 1, you get 6. If you do 1 minus 7, you get negative 6. So that's not right. So we know that we want the 1 to be the one that has the negative. Okay, so now let's fill that in. We want the 1 to be negative, so I'll do x minus 1, and we want the 7 to be positive, so I'll do x plus 7. Now I have factored it completely. Now that I've taken out the correct GCF of 5m, the rest fell together pretty easily. Okay, so let's do a couple more examples of this. What happens if your leading coefficient, so this first term, has a negative in it? Well, you always want to take out the negative. You never want to have a leading coefficient that is negative. So in this first one, there is no number besides the negative sign. So you can think about that as like a negative 1. So take the negative out, and everything's going to switch signs. So if it had a negative, it's now going to be positive. So this would be a positive 2a and a negative 63. Okay, the reason that works is because if we just distribute back in that negative, you would get negative a squared minus 2a plus 63, which if you look is exactly what we started with. So taking out the negative, or dividing by a negative, just flips the sign of everything else, which is why I'm going to write it like this, and we know that that's correct. Okay, once you've done that, you can just factor like normal, and the negative will just stay out in front the whole time, just like it did when we had numbers. So for this one, now I can start writing out my factors of 63. Well, that would be 1 times 63 and 7 times 9. And I'm going to pick the ones that will add to get me to positive 2. Notice I'm factoring here. I'm not factoring this one anymore because we took out the negative, so I'm not even on that step anymore. So make sure that you're actually factoring the step that you're on this step right here. Okay, so I need to add to get to positive 2. And the only way I can get that is if I do 9 minus 7, because that would be 2. So the 7 is the one that has to be the negative. So I'll write that in. X minus 7, the 7 has to be negative, and the 9 has to be positive. And again, the reason that works is because 9 minus 7 is 2, and 9 times negative 7 is negative 63, which is exactly what we wanted. We had a negative 63. So this is my final answer. You still have that, notice I still have that negative right here because we took it out at the beginning and it just stays kind of hanging out in front the whole time. Okay, pause the screen if you need to look this over, and I want you to do the last one on your own. So everybody should be working on this one right now. Pause your screen. First thing you need to do is take out the negative. Okay, so if you took out the negative, it would look like this. But then we notice we don't have a leading coefficient of 1. We have a leading coefficient of 3. So what do I do with that? Well, does everything divide by 3? Because if it does, I could just take out a 3 from everything. And it does. 9 divides by 3, and also 6 divides by 3. So why don't we also take out a 3? So not just a negative, but also a 3. So this 3 would go away. This 9 would turn into a 3 because we're dividing it by 3. And this 6, since we're dividing it by 3, would turn into a 2. So plus 2. Okay, so let me just write that a little bit neater. So it's negative 3 times that whole thing. All right. In other words, you can think about, I took the GCF of negative 3 out of everything, and this is what's left. Now I can factor like normal because my leading coefficient is 1. So write down my factors of 2, and the only factors you would get is 1 and 2. And luckily, those do add together to get you to 3, so we're good to go. So I will write that out. So we need to do x plus 1 and x plus 2. Again, that could be written in any order. And also notice that this negative 3 out in front just stays out in front the whole time. And that's it. That's my final answer. And that's actually it for today's video, you guys. So the main things you need to get is you need to understand that you need to take out a negative if you ever have a leading coefficient with a negative. And if you ever have a leading coefficient that's not 1, then you need to see if all of the terms can be divided by that and also take that out. If you understand that, then that's all there is for today. See you guys.